probability experiment is conducted in which the sample space of the experiment is S, which is 1 through 12. Let event E be 2, 3, 4, 5, 6, 7. Event F be 5, 6, 7, 8, 9. Event G be 9, 10, 11, 12. And event H be 2, 3, 4. Assume that each outcome is equally likely. List the outcomes of F and G, and are F and G mutually exclusive. So for A, to start off with it, all we need to do is actually just simply write out what F has in it and what G has in it. So F is 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, and G is 9, 10, 11, 12. Okay, so we did the first part. We listed the outcomes in F and G. Now, are they mutually exclusive? That's a definition. To be mutually exclusive means they have to have nothing in common. So looking at F and G, there is something in common. Right? They both share this 9. Since they share this 9, they are not mutually exclusive. So F and G are not mutually exclusive. Are not mutually exclusive. So, about right. Easy enough. So let's move on to B. B says list the outcomes in E or H. Find the probability of E or H by counting the number of outcomes in E or H. Also, determine the probability of E or H using the general addition rule. So first, let's list the outcomes. So E has 2 through 7. So 2, 3, 4, 5, 7. H has 2, 3, 4. So we list the outcomes in E or H, right? Those are the outcomes. Find the probability of E or H by counting the outcomes. So then here, we simply count. So probability of E or H by counting. So that's going to be the favored over the total. So the total we know is 1 through 12. So that means there are 12 things total. And now E or H. I have a 2, a 3, 4, 5, 6, 7. So that's 6 numbers. H repeats 2, 3, 4. So we don't need to count those again. Since they repeat, they're non-essential. We simply just need one version of each number. So then there's a total of 6 things. So then by counting, we get 6 out of 12, which is equal to 1/2. Now, they also wanted us to do the general addition rule. The general addition rule looks like this. Probability of E or H is equal to the probability of E plus the probability of H minus the probability of E and H. Where probability of E is simply the probability of E. Probability of H, again, is the idea simply the probability of H. Probability of E and H, that is where they intersect. So that is what they have in common. So probability of E. There are 6 things in E. There's a total of 12. So the probability of E is 6 out of 12. Probability of H. There are 3 things inside of H, so then that's 3/12. 3 out of 12. Finally, the probability of E and H, that's what's in common between the 2 events. What's in common is the numbers 2, 3, and 4. So again, they have 3 things in common. So we're going to take away 3/12. So when we put those numbers together, we get 6/12 again. which is the same thing as 1/2, 0.5, or 50%. Okay, so that's B. Next, let's discuss C. List the outcomes in F and H. Are F and H mutually exclusive? So again, we're going to list the outcomes. So here's F. F is 5 through 9. So 5, 6, 7, 8, 9. H. H is equal to 2, 3, 4. So then, next question, are F and H mutually exclusive? Looking at F and looking at event H, both of them have nothing in common. So since they have nothing in common, these two events are called disjointed, or they are also called mutually exclusive. So our answer would be yes, mutually exclusive. And then finally, D. List the outcomes of F raised to the C. So F raised to the C is the idea of a complement. The complement, in the definitions, simply means everything that's not inside of F. So let's look at this. So here's F. F is equal to 5, 6, 7, 8, 9. Oops, sorry. 7, 8, 9. F complement is everything that's not inside F, but is inside our sample space, our event. So everything else would be 1, 2, 3, 4. We don't count F, so we're going to skip 5 through 9. And then we're going to go 10, 11, 12. So that's F complement. Those are all the outcomes in F complement. Everything that's not in F. To find the probability, we can do the idea of counting. So that's 1, 2, 3, 4, 5, 6, 7. So the probability of F complement is equal to 7 out of 12, simply by counting. Or we can use the formula that says the probability of F complement, any complement, can be found by subtracting the probability from 1. So probability of F complement is equal to 1 minus the probability of F. Now, probability of F is equal to 5 out of 12. So that's 1 minus 5/12. And when you subtract that, you'll get 7/12 as well. Okay, so to recap, mutually exclusive means that they share nothing in common. They are disjointed. They don't touch. They don't intersect. The complement is simply everything that's outside of your event, and it can be found by taking the probability of your event and subtracting it from 1. And then finally, your general addition rule will always look like the P of two events with an OR in between them. And it's just simply the probability of each one added together and then subtract the intersections of those two events, if there is anything. Sometimes there's not. So then the probability of E or F, general addition rule, would be the probability of E plus the probability of F minus the probability of E and F.